All right, this is still dealing with dividing, and as it states, another way to simplify a radical expression is to rationalize the denominator. It says that you rewrite the expression so that there is no radical in the denominator. So like if you glance back at the dividing problems that I just did, like for instance, if you look at the denominator of each of these answers, of course here your denominator is just an understood 1. Here my denominator was a K. Here my denominator was an A. In all three of those examples, I did not have a radical sign left on the bottom, but sometimes you do have a radical left on the bottom in your denominator, and that's what these next couple of examples are going to show you, how to deal with that situation. And that's what's called rationalizing, okay? So, first example, like I said, this is still relating to the dividing. Of course, what you saw that I did first in those previous examples was to reduce what I could reduce, but there's not anything you can reduce here, okay? So what we're going to do is split it back apart, okay? But then I can't reduce either one of these radicals. See, these are both square roots, okay? So if you look at your list of perfect squares, remember a second power is the first thing on here, and you only have a first power, okay? The number 5, of course the number 5 falls here, but yet the only thing below that is the 4, and 4 will not go into 5 evenly, okay? So these happen to both be things we can't simplify, but you cannot leave your answer with a radical on the bottom. So here's how you have to deal with this. This is what's called rationalizing. Take whatever radical it is that you do have on the bottom, and you're going to multiply top and bottom by that radical. Okay? Now, we've already learned how to multiply. So we multiply what we have underneath. So that's going to give me square root of 5x. Same thing here, multiply what you have underneath, so that's going to give me square root of 25. But now, what is the square root of 25? It's just 5. So what you end up with is a radical here that's just going to produce you a whole number. So that way you don't have your radical sign left on the bottom. Now you cannot cancel these 5's because this is under a radical and this one's not. So don't think that you can cancel those. All right, let's look at one more. All right, now on this one, let's write this as one big radical because there is some simplifying that I can do here because my x's, I've got 1x on the top and 1x on the bottom, so my x's are completely gone. So that means I have the square root of y over 3, okay? So now let's split this back apart. So I'm going to have square root y over square root 3. All right, so just like a while ago, I can't simplify the square root of 3, and I can't leave that radical on the bottom, so I'm going to rationalize. So I multiply the top by square root 3 and the bottom by square root 3. All right, so multiply what you have underneath. So y times 3 is going to give me 3y. 3 times 3 is going to give me 9. But then I can simplify the square root of 9. Square root of 9 is just 3.